Hi, I'm Sam Keserly, and this is my presentation on bioprinting for Step 2 of Innovations in Technology for Biology 101 at UMGC. What is bioprinting? Bioprinting is the building of tissues from scratch to explore new cell configurations, printing living cells in a pre-designed pattern. The first attempts at bioprinting were in 1998, and this can be used for tissue regeneration, pharmacokinetic studies, which is the studies of how the medications affect one's bodies, infectious disease studies, tumor studies, and 4D printing. How does bioprinting work? Think of your typical 3D printer, but with adaptations to print with bioinks instead of your typical filaments. In the same sense, a pre-designed structure is loaded into the printer. Benefits of bioprinting. The biggest benefit to bioprinting is how versatile it is. And with technology continuing to evolve, so is bioprinting, like with the exploration into 4D structures. The second biggest benefit to bioprinting would be the possible elimination of transplant lists. The hope is that in the near future, this technology would be widely available to all patients who need transplants and are currently waitlisted. Challenges to bioprinting. There are two main challenges of bioprinting, and that would be the ethical concerns regarding embryonic stem cells and how they are harvested and used, and that adult stem cells, when used, are difficult to obtain, and they also have a limited capacity to differentiate, meaning they're limited in their ability to change and be used compared to embryonic cells. What are stem cells? Stem cells are the body's master cells. They self-renew, they have the ability to differentiate to meet the body's needs, and under specific conditions, they can differentiate into specialized cells. There are two types: embryonic, which are adaptable and they're very versatile, and adult, which are a little bit more restricted in their differentiation potential. How are stem cells used in bioprinting? Bioprinting uses the stem cell's ability to differentiate to create tissues and organs. What is bioink? Bioink provides the environment for differentiation to happen by mimicking the extracellular matrix, or ECM, found in the body. Stem cells are used to create a microgel type of concrete that can then be applied to, say, wounds, for example, with a bioprinter. How is bioink used in bioprinting? Bioink is the foundation of whatever structure is being bioprinted. It mimics the natural tissues. It has been applied to skin, cartilage, and bone. Current research examples. The first current research example that I have is organ on a chip. It's a mini tissue model created for drug and disease research. It allows researchers to test diseases, medications, drugs with specific organs and tissues and see their reactions. The second current research example is that it's used to develop tissues to study different diseases and medication. Similar to the organ on a chip study, this research targets the reactions of tissues to different diseases, medications, treatments, again in both situations without actually risking a patient. Predictions for the future with bioprinting. The hope would be that bioprinting advances so much that there is never again a need for any sort of transplant waitlist or even organ donation. If a patient's in need, it's curated and created specially and specifically for them in that moment. And finally, could my father benefit from bioprinting in his lifetime? Unfortunately, being that my father is currently in his mid-70s, I personally don't think that he will be able to see the benefits from this sort of innovation in his lifetime unless there's some sort of major breakthrough. But even then, those tend to take time to develop and be approved for human use. My hope would be that by my children's generation, my son is 7, that within his lifetime, things with bioprinting have advanced to be able to take people off the transplant list.